this is like technically calculator type thing. So that's why I think it's a great idea to show you this. Or you type in your calculator. And then we'll do inverse sine of that. And you should get 50.8 degrees. Yes, that's the way you solve for E. And then remember, this is again angle side side, so I'm going to check the other one by subtracting 180 minus that. And I think that same thing applies that I told you on Friday. If the angle that you solve for is bigger than the original angle they gave you, I think you only get two triangles. Like if angle A would have been bigger than angle B, then I think it would have. I always check it anyway, because I always feel it. But then after I do it, I realize, yeah. So I'll actually go ahead and solve the rest of this now. So I always have my two separate triangles here. So angle C is going to be 180 minus 50.8 minus 32.5, and that would be minus 6.7 degrees. And then this one is going to be a really small angle at 18.3 degrees. So once you find the second one, it's not really, I don't think it's that complicated to do. It's just remembering how to do it and to check. And then it's just setting up your law of sines 2 more times to find side C. So I'm going to say C over the sine. I'm going to do the top one first. The small angle, 18.3 degrees. And again, it's up to you on how you do this, whether you use A or B. I always use A just because that's what they gave me to begin with. So I would set that up as 5.2 over the sine of 32.5. And honestly, for the bottom one there, I probably would be a slacker and not even show my work. Because all I'm going to do for the bottom one is change that 18.3 to 96.7, right? That would be C over sine of 96.7 equals the same thing. And what I really love about these scientific calculators is that you type it all in once, and ours at least, you go up, you don't have to recheck it. So 5.2 divided by sine of 5 times sine 18.3. If I only go 1 decimal place, that would just be 3.0 on that one. 3.0. And then on the bottom one, I'm just going to change that sign of 18.3. I'm just going to go up and arrow over and change that to 96.7. So for the big triangle, I got 9.6. So I have 3 answers for the obtuse triangle that I made. Well, I guess they're both obtuse triangles. Huh. Guarantee you're going to see one on your test, probably on the quiz maybe soon, okay. And then I just have a couple little story problems. We've done story problems with trig before, but they've always been SOA right triangle stuff, so now we can do that with law sines. So, Forest Ranger Chris at Ranger Station A sights a fire in the direction 32 degrees east of north, and Ranger Rick at Ranger Station B sights the same fire on a line 48 degrees west of north. Find the distance from each ranger station to the fire, and then I forgot to put that at one point in my thread. Station A is 10 miles from Station B. This problem. doesn't really matter really. So Ranger Chris at Station A sights the fire in the direction 32 degrees east of north. I don't like to be a stereotypical girl, but I feel like I'm a stereotypical girl when it comes to directions, because I kind of go in the direction department. But Mr. Bain always, I never knew what he was talking about, because he would always talk about the word west or but if this is north, right, east of north would be this way. That's right, east of north. That's right. So, here's what I think is tricky about this. 32 degrees east of north, that's not the angle in this triangle. That would be this angle. That's true. 32 degrees east of north. What do you think 32 degrees? I think 32 degrees is in here. That's 32 degrees east of north. I think it's in here. If that's east of north, which means you can subtract from 90. You get that should be 58 degrees. And the only time you have to do that is when they give directions like that, east of north. And Ranger Rick over here at Ranger Station B, again, this is north. And so he's sights the fire on a line 48 degrees west of north. So 48 degrees from north, that's why it's up here. So that would be 48 degrees. Which would make this in here 42 degrees, is that true? And they tell us that they're 10 miles apart. They want us to find how far each ranger is from the fire, but you got to be really careful when you label those, because I'm going to label this B and this A. Little B is actually the distance from station A. I can find that third angle pretty easily, right? That is a subtraction 180. So just like every story problem, it's like getting the picture right so that you can set up the problem. So then this is 80 degrees, which again, I know this is 80 degrees. We cannot do Pythagorean theorem because it's not a right triangle. But what we can do is we can set up a law sign problem. So I can just say B over the sine of 42 equals 10 over the sine of 80. And I'm just going to do the same thing for A, and then I'll solve it on my calculator. So I could say A over the sine of 58 equals 10 over the sine of 80. I got 6.8 miles for little b, which is actually the distance from station A, and then I got 8.6 miles from Ranger Rick at station. Two observers are 600 feet apart on opposite sides of the flagpole. The angles of elevation from the observers to the top of the pole are 19 degrees and 21 degrees. Find the height of the flagpole. So we know how far to go with the pole. It's not over here. Oh, that's pretty long. 600 feet apart, so I know this whole distance is 600 feet. They don't tell me that 13, like, it doesn't say 300 and 300 feet. It can't say, like, that'd be easy to say. And remember that the angled elevation is, like, from the ground looking up, like, and you're really accurate. The angled elevation would be from your line of sight, and you have to subtract your height. The from the ground are 19 degrees and 21 degrees. It doesn't matter which way you label those, but I'm just going to 19 degrees and 21 here. The top angle for the whole big triangle, not the two little triangles. This is 140 this whole thing up here is 140 degrees. Again, they're not equal distance. You can't cut that in half. Can I find the height of the flagpole just starting off? I can't. I have to find one of these sides first, and then I can go back and find the height. You don't have to find both, so it's kind of up to you on which one you want to find here. But you either have to find this distance or this distance, so that you have enough information to find the height. So it doesn't matter. Chloe's already put Chloe in there. So Chloe, did you use 19 or 21? So Chloe used the angle 21, so that means she's finding this distance. So I'm going to call that X. I'm just going to set up a wall sign, and I'm going to say X over the sine of 71 degrees equals the one side I know is 600 over the sine of 140 degrees. And I get that X is 334.513. I'm just going to go a few decimals on this. That would be this distance. Oh yeah, we're hoping. And so then to find the height, since we're hoping that the flagpole will be we could just do so now, right? Like we could set up flagpoles that are tangent. You could set up another wall sign using that. Wall sign does work in right triangle, but when it's a right triangle, to me, it would be much easier to use 19 degrees. That would be opposite over hypotenuse. So we could say that the tangent of 19 degrees equals h over 334.513. I got 115.2. Whoa, I'm an idiot. This should be tangent, right? What should this be? Opposite over hypotenuse is not tangent. Right? So we can use SOHCAHTOA, you just have to use the right frequency. Feel free to tell me when I make a dumb mistake. Then I get 108.9. I'm just kidding. And 18. 17, there's a picture in your book. 18 was also kind of like that. And then 21 is a hot air balloon. 25 is about a torch. But they shouldn't be too bad to do. You don't have their questions about it. But probably have to, but you still have some stuff over if you have questions.